Hello everyone, welcome back to Educquiz. So we are on the exercise number 3, the chapter Matrices. So this exercise goes image of the line 2y is equal to x under the transformation matrix operator this. And Roman 2, find the inverse of the matrix A where A is ace, hence solve the system of equations this well. This Roman 2 is. I've been doing it over and over. So find the image of the line 2y is equal to x. Under the transformation matrix operator this. So we have this line. They're asking us to find the image of this line under this transformation matrix. How do we do that? To be equal to t. You imply 2y is equal to t. If x is t, implies y is equal to t. So if x is t, then y will be t on 2. Then this will imply if you multiply that transformation matrix by xy, which is actually t and t on 2, we are going to have x prime, y prime, where x prime and y prime is the image of it. So they're asking us to find the image. They're asking us to find the image of this line under this transformation matrix. So x prime, y prime. When I multiply these two like this, what am I going to have? 0 times c is 0. Negative 1 times this, I have x prime is going to be negative t on 2. That is for x prime. For y prime, is going to be, so I do this and this to find my x. I'll do the second one down. I'll have negative 1 times t is negative t times this. I'll zero, that is 0. So I have y prime as this. So I'm almost done. Now they're asking me to find this image. Have it in terms of t, but here the image is just in terms of x prime and y prime. I don't want it in terms of a third party. This third party is in case you put your own value. 6. If you have 6 here, you must have 6 on 2 here, because that's a relation that was given to us. X is 2 times y. X must be 2 times y. So if you have 6 here, you must have 3 here. So that's why you have t, and you don't just use x and y. So t is just something which you can replace. But x prime and y prime is not in terms of t again. It should be how the answer looks like. So since I don't want t, I can just put this t here. Here. Question saying again. Just negative 1. Negative 1. Okay. Let's assume this is equation 1. This is equation 2. Putting 2 in 1, we have, replace the negative t here, we have x prime will be equal to, this is the negative t. Just putting y prime there. Y prime on 2. Which implies x prime 2x prime is equal to y prime, which implies, from down here, this implies y prime minus, if I bring this behind, I'm going to have it minus 2x prime is equal to 0. They gave me the image of a line. I should put that image back in a line 4. So I should change it from this to that line 4. That is why I make it like this. And I have it in line form as y minus, so y prime minus 2x prime is 0. So that is actually it. That is how it is done. So here, if you leave it like this, you'll be correct if they ask you to leave it in parametric form. But since they give you a line, you have to change it back from the parametric form to the linear form. And this is it. So here it is. And solve the system of equation. I've been doing that. So let's just trash it. Let's trash it. Inverse of the matrix A, where A is that. Okay, what is A? A is, why am I recopying A? Okay, so, well, let me just recopy the A. I have 1, minus 1, 1, 2, 1, minus 3, 1, 1, 1. Okay, so the determinant of A, well, I know that the inverse of A is equal to 1 over adjugate, where the adjugate is the cofactor, is the transpose of the cofactor of matrix A, the adjugate of A. So I'll firstly find the determinant of A. What is the determinant of A? I know that this sign is plus, minus, and plus. So I use my 1, I cancel the column and the row. I have 1 minus 1 times 1. 1 minus 3 times minus 1. 1 times minus 3 is minus 3. So I have minus 1, which will be plus 1 into these two multiply. I'll have, I cancel this and this. I have 2 times 1, which is 2 minus 1 times minus 3, minus 3. Plus 1 into, I cancel this and I cancel this, I have 2 minus 1. So I'll be left with 1 into 4. So it is 4, here it is, plus 5, here it is, 2 minus 1, plus 1. So it is 5 plus 5, 10. So my determinant is 10. I'll keep it somewhere here. So when I have my determinant, I can now go and find the adjugate, where the adjugate is a cofactor transpose. So I'll proceed with finding the cofactor. So to find the cofactor, I have to find the cofactor at each point. So what is the cofactor? The one we just before with the sign plus 4. Cofactor at 2 will just be 5 with the sign minus. So it is minus 5. Cofactor at 3 will just be 1 with the sign plus. So it's 1. So what is the cofactor at 2? You cancel here and you cancel here, you have minus 1. This sign is minus. You have minus 1 times 1, which is minus 1. Minus 1 times 1 is minus 1. Minus 1 times 1. With the minus behind, not forget. Cofactor at 1. You cancel here and here, you have 1 times 1, which is 1, minus 1 times 1, which is 1. So it's 0. Cofactor at minus 3. Cancel here and here, you have 1 times 1, which is 1. You have 2. So this is plus, minus, plus. Here I'm going to have minus 2. So the cofactor at 1 down is going to be cancel here and cancel here. You have 3 minus 1 is 2. The sign is plus, so it's 2. Cofactor at the one next, you have cancel here and cancel here. You have minus 3 minus 3 minus 2 is minus 5. So I plus minus plus minus plus. So lastly, I have 1 minus 1 minus 2. 1 minus minus 2. This 1 times 1 is 1 minus 2 times 1 is 2, but due to the negative, it's minus minus 2. So 1 minus minus 2, it is 3. Sign is plus, I have 3. Here I have negative into minus 1 is minus 2. Minus 2 times the negative will change to plus 2. So the cofactor of x 2, 0, minus 2, 2, 5, 3. So the cofactor transpose or the aggregate is so is 2, 0 minus 2, then 2, 5, 3. So when I find that B here is inverse, A inverse is going to be 1 over determinant times cofactor transpose. My determinant is A. I don't know into how many pieces I've been breaking this chalk. My determinant is A. Determinant, which is 10. So A inverse is going to be 1 over determinant times adjoint, which is equal to 1 over 10 times I have 4, 2, 2, minus 5, 0, 5, 1, minus 2, 3. It is equal to 2 and 5, 5, 1 and 2, negative 0, 1 and 2, 1 and 10, minus 1 and 5, 3 and 10. This is A inverse. So we found the A inverse. The system of equations, hence, solve the system of equations this. So what is the system of equation? If we look at the letters, we're going to see that the coefficient of each of these letters is this. All of these numbers are here. So if you put this system of equations in matrix, when we write it, we are going to have actually the matrix A. We're going to have the matrix A times x, y, 7 minus 6, 4. 7, 7 minus 6, 4. Yeah. So to find x, y, and z, I'll have 7 minus 6, 4 times A inverse. So x z will be equals to 7 minus 6, 4 times A inverse. So I have my A inverse. I'll just multiply that by 7 minus 6, 4. Find my x, y, and z. So let's do that right now. So I'll put 7 minus 6, 4. And I put my A inverse. 2 on 5. 1 on 5. 1 on 5. Minus half. 0. Half. 1 on 10. Minus 1 on 5. 3 on 10. Okay, so when I multiply that, I'm going to have x, y. Z equal to, I want to have x first. I'm going to multiply this column by the first row. So 7, I'll have 14 on 5 plus, since it is minus, I put my minus 6 on 5 plus 4 on 5. Since all of it is on 5, I can just multiply, I can just add up the numerators. So I have 14 plus 4, 18, minus 6, 12. That is 12 on 5. Y is going to be uh, minus 7 on 2, 0 here. So this is going to be 2. Minus 13 on 4. Z is equal to, multiply this by the last one I have, 7 on 10 plus 6 on 5 plus 12 on 10. That is going to be, if I multiply this up and down by 2, I'm going to have 12 here and I'm going to have 10 here. So I can add 24 plus 7. 24 plus 4 is 28. 5, 6, 7, 29, 30, 31. Okay, so that's x, y, and z. So to finalize, you can write x, y, and z this way equal 12 on 5 minus 13 on 4, 31 on 10. So that is going to be your answer. Thanks for watching it. You can go ahead and try to solve exercise 4. So thanks for watching, and